All right, it's time to get a little routing going. Configuring routing with OSPF. Now, at this point, we actually have, let me just kind of hit the high points of where we are. We've got the branch office completely set up. We've got VLANs configured. We've got the switch that is now able to route between all the different VLANs. We've got the internet connection working and tested. We've got a VPN tunnel going between the two sites. This side is able to ping across the VPN, and we verified that the VPN is indeed working. So we've got full connectivity between our offices. And there's a big question that might be rolling through your head, which is, why do we need routing anyway? I mean, it seems like weren't we able to ping between both sides? We were able to ping from switch 1 to switch 1 over here, corporate switch 1. The VLAN interfaces, everything seems to be working. Why add OSPF? Well, that's a good question. I would say the only reason this is all working is because it's so small. Meaning, right now, the reason it's all working is we have a default route at both locations pointing out to the internet, saying pretty much send everything that you don't know about to the internet. So it just so happens when let's say this PC decides to send some traffic over here to the switch or some PC connected on this side of the game, it's going to go out here, hit the default route, which says, okay, send it to the internet, and right there, our VPN configuration intercepts it and says, oh, no, this is interesting VPN traffic. Let's go ahead and tunnel it through to the other side. And it works simply because everything, regardless of whether it's going to the corporate office or going to the internet, is all going out the internet connection. So it makes it very simple of a topology, but what would hose everything up is, let's just go ahead and say we add Nugget Lab branch office 2. Let's say branch 2. Now we've got a default route going here. He's sending everything this way, but now we've got an issue because this guy doesn't know which subnets are on this side. It doesn't know what subnets are over here. We need to have good routing. We need to have routing in place. We can't rely on a default route to take care of everything. So why not start it right from the beginning? And we're going to start off with OSPF. So let's bring the scenario into the picture. And let me read through this. I put the scenario. Now that the Nugget Labs branch facility internet and VPN connection is functional, you would like to implement OSPF routing between both offices. Because Nugget Labs is growing, you intend to design their OSPF network. I just realized slightly cut off. Wow, that's too small though. That's all right. Believe me when I'm reading. You design their OSPF network for scalability, implementing the corporate office as the backbone, and their first branch office is a different area, which allows summarization in the network. Okay. Well, let me summarize what that's saying. We've got two major locations. We've got the corporate office. Let me go back to my whiteboard. Corporate office right here, and I said I want that to be OSPF area 0. Over here, I want this guy to be OSPF area 1. So a couple of thoughts that might immediately come to mind on that is, number one, why are we doing that? Well, breaking into multiple OSPF areas is what allows us to summarize. We can't summarize without having multiple areas. OSPF doesn't offer that ability. EIGRP does. There is no area concept in EIGRP. So, but with OSPF, technically, this is how it looks. This, I know I didn't go as big as I needed to. This is technically area 1. This, and everything back here, is technically area 0. Because it looks like, well, this office starts area 1 with the way I have it labeled, but that's not how OSPF works. OSPF works, it sits on the links. So really, this guy right here is known as an area border router, meaning a router that has interfaces in more than one area. That router is able to summarize routes, and we'll get more into that later. But second question that might be coming to your mind is, wait a sec, isn't multi-area OSPF beyond the scope of the CCNA exam? I would say, well, looking at the test objectives, no, because the test objectives say configure OSPF. As of right now, all of the Cisco feedback and material does suggest that OSPF is only in area 0, and let me just be frank with you, that's the way it is today. You only have single area OSPF today, but two thoughts on that. One, if you want to be able to summarize and make routing more efficient, you got to have multi-area OSPF. It's not possible otherwise. So real world wise, you're going to use multi-area OSPF in almost every situation where you want summary routes, which we do in this case. Second thing is CCNA exam changes all the time, and the test objectives for OSPF are vague enough to suggest that they could flip to a multi-area configuration at any time. But all that being said, let me put it this way. I'm going to break this. I'm foreseeing here. I'm going to break this into two nuggets. The first one, I'm going to go through the base configuration of OSPF, get everything working between our two offices. Second one, I'm going to get into the fancy stuff, changing hello timers, modifying summarization, creating summarization between areas. Things that I would consider probably beyond the scope of the typical CCNA. So to focus you, if you're just hardcore CCNA, like give it to me, nothing more, then just watch this one. If you want to go beyond, go ahead and watch the next one. Come on, just watch it all. It's good stuff. So let's, one more thing. I put it in red, and of course I scrolled right by it. I put note to say somewhat within the CCNA exam requirements. Assume the ISP has created a private MPLS connection on the 172.30.124 networks between the branch and corporate office. What does that mean, Jeremy? Here's what it means. It means that normally if you're doing routing over a VPN connection, which I set up simply because of the feedback that you guys gave me, you got to go all out. You got to create virtual interfaces, enable those virtual interfaces for routing, use GRE tunnels. I mean, it gets, I'm not saying it's impossible. It's just, it's not, like, to do it, I would have to add a lot more to the VPN side of things, and I think that would start melting people's brain, and I don't want to do that. So what I'm assuming is, let's just say this is an MPLS connection. This is actually very common today, to where we actually have a direct link between our offices through the service provider, and they provide internet connectivity from that MPLS cloud. So it's kind of like we have a private cloud, if you will, between our two devices. So we can, the point is we can send OSPF across the 172.30 network right here, through this little private cloud that we have, and they'll have hellos, they'll have neighbor relationships forming. These two routers will believe that they are directly connected right here. That's a lot of what happens in the MPLS world. So that'll help us tone down the VPN side of things a little bit. So with that being said, let's get into it. So we've got the requirements. I said to help guide it, we've got this. It says, number one, let's read this. Configure the Nugget Labs corporate office to support OSPF. So we've got corporate router, OSPF. This is going to be the OSPF ABR. Should use the router ID 1.1.1.1. Now, in these instructions, there's sometimes where I leave things vague, meaning uses the router ID 1.1.1.1. Well, if you study OSPF, you find there's actually a couple ways that you could do that. I could go in and create a loopback interface on router 1 and give it the IP address 1.1.1.1, and assuming that's the only loopback interface, that automatically becomes the router ID. The router ID, by the way, by default is the highest IP address on the router unless you create a loopback interface. Then it's the highest loopback interface. So that would be one way to set it. However, Cisco's recommended way is router ID. You actually type in the command underneath OSPF configuration mode. Now, to talk test-wise, let's say you get this kind of statement on the test or on the exam. What do? I mean, do you do Cisco's recommended? Do you do the loopback interface? If they leave it vague like this, and let me make sure I say this exactly the way I want to. If they leave it vague to where they just say this is what you need to do, then do it however you want, or ... however works. A lot of times you'll be on the exam and you'll try something and it'll say, oh, sorry, that command is not supported, and you're like, oh, okay, that's not how they want me to do it then. So then do whatever works. But if they don't tell you exactly how they want you to do it, then they are leaving it open to your interpretation. So that's one of the things we'll have to do. OSPF should run on both corporate router 1 and corporate switch 1. Remember, this is a layer 3 switch. It has the ability to run routing protocols, and we'll need to do that. The switch will have the router ID 1.1.1.2. All VLAN interfaces on the corporate switch should be considered configured as passive with the exception of VLAN 1. If you haven't seen that before, what is a passive interface? What it is an interface that is advertised and yet doesn't form neighbor relationships. Here's what I mean. On corporate switch 1, I think I have created 3 VLAN interfaces just for testing. I've got VLAN 1, VLAN 2, and VLAN 3. Now, normally, typically, those are my little staffs that come out of it. That's the routed interfaces. Those would connect to a user community. We would have, a bunch of computers that are maybe in, let's say these are all in VLAN 3. And they connect to this, get routed, move off to the internet. Again, going back to the difference between VLAN interfaces and creating a VLAN. VLAN puts people into it, isolates them. Creating VLAN interfaces gives them a routed interface out of their VLAN. So with that being said, a passive interface, let me back up a little bit. When you are adding interfaces to OSPF using the network command, you go router rip or router OSPF, and you type in a process ID, and you type in network, let's say 10.1.1.0 with a wildcard mask 0000255. So it says, I'm going to advertise that network to the rest of the world. Well, let's say that's VLAN 1, right? It's going to say, I'm going to advertise that network to him, and he'll advertise it to the rest of the world. That's how routing protocols work. But the other thing it actually does is begin sending hello messages out that interfaces. It starts trying to form neighbor relationships on VLAN 1. Well, that's dangerous. Because if VLAN 1, or in this case VLAN 3, connects to a group of users right here, and you're sending out OSPF hellos, a malicious person can grab that hello message and kind of engineer a reply and form a neighbor relationship with your device. Yikes. Now, OSPF authentication helps a lot with that, but recommended practice is, boy, why don't we just enable these as passive interfaces, which says still advertise that network, meaning let everybody else know that that network does exist, right? So you're advertising it, but don't send hello messages. No hello. So that's what a passive interface does for us, is turn off hello messages so we can't form neighbor relationships on those interfaces. Good news. So that's what they're wanting us to do. So it says, passive interface VLAN 1. All networks internal to the corporate office should be in area 0. Networks connecting to the branch office should be in area 1. So going back to our diagram here, that's going to be networks connected to the corporate office, area 0. Networks connected to the branch office, area 1. Again, the diagram here isn't showing the true area boundary, which is this. This is all in area 1, but this interface of this router will be in area 1 as well. Okay. Devices should use secure or hashed OSPF authentication to ensure rogue devices cannot join as OSPF neighbors. Use the password Cisco, which is super secure, when forming all neighbor relationships. Only non-passive interfaces need to be configured for OSPF authentication. See, this is kind of a double backup, if you will, to say, you know what, I don't trust your hellos unless you also tell me that you're using the secure password Cisco, which we came up with right now, to create a hash for your data. I'd love to, but I just don't have time to get into the hashing concept. But it's a fun one if you ever want to talk about it. So we'll configure authentication. And then finally, it says use only one OSPF network statement with an exact wildcard mask to advertise corporate networks. Use one additional OSPF network statement with wildcard mask of 0000 to form neighbors in area 1. Okay, big thing I want to point out. Actually, really big thing on this. Number 1 is when you're on the exam, be so careful. Be very careful to read the full objectives for this before you get started. Because I'll tell you, and it's funny, when I wrote this, I actually had this originally as one of my first statements, and I moved it to the bottom just to prove this point. A lot of times what you'll have is people, and I do this just as well, you get on the lab, on the exam, and you're going, you immediately say, okay, corporate router should have router ID 1.1, and you're like, okay, router OSPF, router ID 1.1, enter. And hopefully you don't hit your keyboard that hard. And you go, okay, should be, okay, so I need to, okay, you're typing in network statements, and so you get to the end and you're like, you get this statement, and it's saying you can only use one network statement with an exact wildcard mask to advertise corporate network. You're like, I didn't do it that way when I did it up here, so you got to go back and do no and get it all out. You've wasted time doing that. So always read all objectives to put them together. So now, Let's talk about what it's saying. It says use one network statement. Again, that's how we advertise our networks with an exact wildcard mask. I was trying to think of a better way to write that. I just couldn't find a good way. Meaning, there should be one wildcard mask that we can type here that will advertise all of the corporate networks into OSPF as area 0. And then it says use one additional OSPF network statement with a wildcard mask of all zeros, that's a very specific one, to advertise area 1, which will help us identify that interface. Okay, so I think we're ready to go. I've talked through this enough, given you enough conceptually around it. Let's do it. I'm going to open GNS3, and you know what? I think it magically fixed itself. In the last time I did this, I couldn't start this switch in this PC because I don't know why. It just kept crashing, and now it works. So I've got router 1. Actually, that's not what I need. I need corporate router 1. That's where we're beginning. So bring that into the picture and resize this. And here we go. Squish this up just a little bit more. There we go. So corporate router 1, I'm in. Show IP interface brief, just because that's what I do. Okay, so we've got our interfaces. There's our MPLS internet connection. And down here are all the internal networks. We've got a router on a stick kind of configuration going on at the corporate office. So this is just for our 3 test VLANs. So, okay, let's back up now. I also want to, hang on, let me open up the Excel spreadsheet, which allows us to see the corporate office. Okay, so this is a summary route for the corporate office, this guy right here. So I'm going to just kind of keep that in the back of my mind. That'll come into play. So the first thing that we need to do is go in and enable the OSPF routing process on corporate router 1. So we do that, global config mode, router OSPF, and then you type a process ID. I always use 1. It's just the first number my finger hits. And now I'm going to set the router ID just like it said I should. Now, it says I mentioned I can use loopbacks, but man, Cisco's recommended method is router ID 1111. Now, if you have formed neighbor relationships and do that command, it'll say, hey, you have to clear the OSPF process before that will take effect. But since we don't have any neighbors, it will take effect immediately. Says, okay, OSPF should run on corporate router 1 and corporate switch 1. It mentions the area 0, hash authentication, network statement. So I'm kind of taking this in the big picture sense. I'm going to get OSPF fully running on router 1, I would say minus authentication. I want to make sure that the neighbor relationships form without having authentication, because that just adds one more piece that we have to figure out. So let's do our network command. So I'm going to do network. It says, okay, what is the network number? So when I think of it, an exact, when it's saying right here, use an exact wildcard mask to advertise the corporate networks. I'm thinking of one that matches exactly, like it's saying, to the summary route that represents the corporate office. So the way that we do that is I look at that summary mask. So this, if I take 10.1, where's my whiteboard? 10.1.0.0 with a 255.255.192.0 subnet mask. Remember, this gives us that increment of 64. If you break that out in binary, 192 is 1100000. Lowest network bit is 64, so that's our increment. So really, that gives us the range 10.1.0.0, and then we just add 64. 10.1.64.0 to that octet, because that's where it's lining up to. And I go, okay, well, that's where the next network range starts. So the corporate office is 10.1.63.255 is the last IP address at the corporate office. That's our range over there. And you know that's why our branch office starts right here at 64. All of that is kind of peripheral information just to get you familiar with how we came up with that summary mask. But now we need to convert that to a wildcard mask, because Cisco's crazy and they came up with this wildcard mask concept, which is backwards. And the easiest way to do it, this is how I always do it, is just take all 255s, and subtract your subnet mask. So the wildcard mask that would get the corporate office is 0.0.63, that's a weird one, .255. Forgive my math problem from getting a little sloppy here, but that's the wildcard mask that will encompass this whole range. So when I go into OSPF right here, I can do network and then do 10.1.0.0. It says, okay, what is your wildcard bits? 0.0.63.255, which encompasses all of these, essentially every subnet that might be provisioned at the corporate office, these three included, but again, our spreadsheet showed us this whole range. So that's what I'm going to include. And then it's going to say, well, what area is that in? And I'll say, well, that is area 0. Good. Got that configured. So now OSPF, if I think about it, OSPF is now running on my router on a stick kind of configuration between these two guys. Now, I set up the corporate office a little weird because all of our focus is really the branch office. The corporate office is just kind of fun. But I have router on a stick configuration here, but I actually have 3 VLAN interfaces configured on switch 1. That's not normal. You don't normally do it that way. The only reason I did that is because I wanted switch 1 to act not only as a layer 3 switch, but also as PCs that we could ping. So I created some additional VLAN interfaces over here just so we could ping them. They would work, all that kind of stuff. Yes, there's probably a different way I could have gone about it, but I didn't. So now when we come over back to the router, let's get the other network command out of the way. I'm gonna, remember in the instructions it said use one additional OSPF network statement with a wildcard mask of all zeros to form neighbors in area 1. Well, area 1 is the MPLS cloud. That's this guy. So if you're using a wildcard mask of all zeros, that means you're using the exact IP address. So we say network, shoop, and the wildcard mask just says, okay, what bits are significant? Every single one of them. This is actually a great practice to enable OSPF. It says turn on OSPF on specifically that interface, that IP address, that subnet. Now, remember, the network command doesn't actually tell what networks are advertised. Hang on, let me revise that last statement. When I type in this command, it's not like OSPF is now going to advertise and say, hey, I now know about the 172.30.2, what did I put, 100.240 IP address. It doesn't advertise that. It's still going to advertise and say, hey, I know about the 172.30.100.0 network. It realizes that that's just an IP address. It's looking at the interface to get the real subnet mask. So that does not impact what is actually advertised. So I'm going to say we've got this network in area 1. Just like that, I've created an ABR. There is no I'm in an ABR command for OSPF. It's just when you put two network statements in different areas, the router automatically knows. It's like, oh, well, this is area 0 and this is in area 1. I must be an ABR. So that's all there is to configure in an ABR. So we've got that piece configured now. Let's head over and configure the layer 3 switch. So I'm going to jump, actually I need to go to GNS3, open a console connection, and I'm in. So we've got switch 1, and let's do a show IP interface brief. Got a few switch ports, and then we've got the VLAN interfaces. Okay, so I'm going to go in and do a router OSPF 1. Now, the lab said that the router ID for this guy should be 1.1.1.2. So, let's do router ID 1.1.1.2. And then I'll do the network command. It says use only one OSPF network statement. So I'm actually going to hey, let's save some typing, right? I'm going to come over here and take this guy, which is the same one that we'll use for the switch, jump over here and paste it in. Poof. And look at that. We immediately get a neighbor forming. Oh, look at that. We've got 3 neighbors forming. Who are these 3 neighbors? Let me do a show IP OSPF neighbors. And I see they are all 1.1.1.1. The router ID 1.1.1.1. It's all going to the same place because, again, remember I told you this is a weird setup that I've got. I've got 3 VLAN interfaces configured on corporate switch 1, essentially connecting to 3 interfaces on corporate router 1. So it's like, hey, I'm a neighbor, hey, I'm a neighbor, hey, I'm a neighbor. So I'm forming duplicate neighbors. So this is where the passive interfaces are going to come in handy. So check this out. It says all interfaces on corporate switch 1 should be configured as passive with the exception of VLAN 1. Let me show you how I do this. And this is, again, another good Cisco best practice. I'm going to go under switch 1, router OSPF 1, passive interface, and you notice you can either type in an interface, which ones do you want to make passive, and I could say I want to turn off this interface, I want to turn off this interface, with the exception of VLAN 1, but the better way is actually to do a passive interface default, which you can see right there in the description. It says turns off all interfaces, and as soon as you see that, it's like neighbor down, neighbor down. We just lost all our neighbors because we're not sending that. So you might say, well, how do you turn on VLAN 1? Well, we type in no passive interface VLAN 1. Now VLAN 1 is the only one that is back up and running, and now we've got VLAN 1 as active again. Pretty cool, huh? So now we actually have, if I go back and do a show IP OSPF interface, I'll see that VLAN 1 is up, and you notice it says I've formed a neighbor on this. Neighbor count is 1. Here is the adjacent neighbor. He's the designated router. But when I look down at the rest of them, I'm seeing, okay, there's no neighbor counts because there are no hellos being sent out. This is a passive interface for VLAN 3. This is a passive interface for VLAN 2. So yes, these are included in the OSPF process. I'm advertising these networks. However, I am not sending hello messages out on those interfaces, which I think that's pretty cool. So let's also do that because it didn't really specify. It just said all. Oh, okay. For switch 1 should be configured as passive. Okay, I was going to configure router 1 as well, which would be a little more secure. But since actually it just said switch 1, so I'm not going to do that now. So we've got corporate office area 0. Okay, good. So now let's do the authentication. Devices should use hashed OSPF authentication. Let me show you. The OSPF actually supports 2 kinds of authentication. One is clear text. Nobody should use that because it sends the password with every single packet. The second one is hashed, where it's kind of, I'll use the word encrypted, even though it's not encrypted. It's just adding a hash at the end of every packet, which makes it secure. You can't form a neighbor relationship unless you have the right password. Now, OSPF authentication is enabled on a per interface basis. So I'm going to go underneath the interface that is forming, because they're all passive now, except for VLAN 1. So I'm going to go under the VLAN 1 interface and then the right interface on this side and turn on authentication. So right now I'm on router 1. So this interface right here is what matches to VLAN 1. That's the .1 on the other side. So I'm going to do interface FA0/1.1. And it's really just 2 commands. IP OSPF authentication. And if I wanted to do clear text authentication, I would just hit the enter key right there. And it would say, okay, we're going to use clear text. But I'm saying, no. I want to use hashed authentication, which most people know as MD5 or message digest authentication, message digest 5. So I'm going to type in authentication message digest, enable that. And then I'm going to type in IP OSPF message digest key. I can configure multiple keys. I only need 1 because I only have 1 password. But this is a feature that allows us to change passwords without causing an outage, because I can have multiple keys and kind of remove one and everybody starts using a different key. So I'm going to say message digest key 1 MD5. I don't even know why they have you type that in, because you obviously specified message digest key over here. But then it says, okay, what is the key? Well, it said the key should be Cisco. And by the way, before I even type this in, well, let me hit the enter key, because now I've added my key in there. But I want you to notice, before I even did that, my neighbor relationship died. Neighbor down between them. Now, why did that happen? Why did it take so long? Well, I turned on authentication. I said right here, enable authentication, and this says, I now require authentication to be used for my neighbors. Well, corporate switch 1, which is the other side, is still sending hellos without authentication. So what's happening is they're not the hellos are coming in. He's not replying back because he's saying, "Hey, these are no good. I need authenticated packets." This guy's saying, "Well, hello, hello, hello," and eventually, after I think it's 40 seconds is the default downtimer. After 40 seconds, this guy says, "Okay, nope, sorry, you are no longer responding my hellos. Let's terminate this neighbor relationship." So that's why the neighbor failed. So how do we fix it? You're probably thinking, well, got to enable the other side for authentication. Let's do show IP interface brief. There's my VLAN 1 interface. That's the only one that needs to be configured because you might remember in the lab it said only non-passive interfaces need to be configured for OSPF authentication. Saves us some work. So let's do interface VLAN 1, which is the one connecting to router 1. And we'll do IP OSPF authentication message digest, enter. Well, that's great. And now he's saying, okay, my authentication flag is turned on. Woohoo! But the other side is saying, you don't have the right key. So we're going to say IP OSPF message. OSPF. Message digest key. We'll use key 1. By the way, the key number does have to match as well as the key itself. So we'll say key number 1, MD5, and we'll use Cisco as the password. I hit enter. Hold my breath. Well, there we go. And there we go. I didn't have to hold it for long. We can see the neighbor has now gone from loading to full. The reason it took a little bit is because, remember, show IP OSPF interface. Let's just look at VLAN 1. This guy's only saying hello once every 10 seconds. So we enabled OSPF authentication, but we had to wait for a 10-second timer to occur. Dead timer is set to 40 seconds. Good. So I would say that is awesome for the corporate office. We now have the corporate office running, neighbor relationships formed, but we're not going to see any routes yet because corporate switch 1 and router 1 all know about the same stuff. So what I'd like to do before we close out this nugget is get the branch office configured. We'll be able to go much faster because it's the same exact steps. It's just different devices. So let's just shoot over there. I'm going to go over to the branch one, and it said this guy. Let's just hit the high points. Router ID right here. OSPF should run on both of them. The switch should have this router ID. You can see that's different from the router IDs up here. All networks should be in area 1, but look at this. You may not use network commands under the OSPF routing process to advertise these networks. You say? That's going to be the what I would call the new improved way of advertising OSPF networks. If you haven't seen this, you're going to love it. And it says all VLAN interfaces on switch 1 should be configured as passive with the exception of Fast Ethernet 1/15, and we'll see what that looks like in a second. Devices should use authentication, same thing as before, right? All right. So let's go into router 1. And let's do router OSPF 1, router ID 1.1.2.1, which is what it said it should be set to. And then it says, and again, I want to emphasize this again, it says everything should be in area 1. You may not use network commands. Now, if you haven't seen this before, you might say, well, how else can you do it? Well, OSPF actually introduces a way of the future, meaning in the future, this will be the only way that you're able to turn on OSPF. And what I'm speaking with that is when we move over to IP version 6. The network command, I will tell you, is one of the most confusing commands. You know, when you type in network, because it does two things with one command. That's, you know, what I just explained with the passive interface and all that. And it just blows people's mind. So another way that we can, hang on, let me type this. Another way that we can enable OSPF is under each interface, and I love this. Let's go under interface FA 0/1, and the command is going to be IP OSPF. And I'll hit the question mark, and you say, whoa, you know, a bunch of stuff. You might go, oh, well, network. Well, that's actually just sets the network type. It doesn't do anything. Oh, I lost my mouse. There we go. It sets the network type, what kind of network it's connected to, but it doesn't do anything for advertising it. The way that we can do it is say IP OSPF and tie it to the process ID. We created OSPF with process ID number 1 right here. So I can say, okay, assign this interface to OSPF process ID 1, and we'll put this into area 1. That's it. That's all there is to it. And that now enables it under this interface. I do the same thing. I go under fast Ethernet 0/0, IP OSPF 1, area 1, enter, and I've now added that interface in there as well. And notice, did you see it? Excitement! I can't wait. It's formed a neighbor relationship over, with this neighbor over the WAN, which is corporate router 1. Let's look at corporate router 1. And notice corporate router 1's reporting. He's saying, I formed a neighbor over the WAN with this. That's our branch router 1. So we've got our first neighbor. So we should get some routes. That's what I'm thinking. Yeah? Let's check it out. Show IP route. Mm-hmm. I love it. So we've got OSPF routes, not just OSPF routes, OSPF inter-area routes, meaning these networks exist outside of your area, router 1. I'm speaking to router 1 when I say that, metaphorically, because router 1 is all in area 1, so it's saying, oh, these are routes outside of your area. Well, where are those routes? Area 0. They're all from the corporate office. Remember, corporate office, this is all OSPF area 0. This is all OSPF area 1. So it realizes those came from a different area. Can't you just look at that for a little longer with me? Oh. Okay, so we've got router 1 set up. Got some OSPF inter-area routes. Now, one of the things it did mention is to use OSPF authentication everywhere, so that includes the WAN links. We got to remember to come back to that. But for now, let's jump over to switch 1 and get switch 1 configured. Now, switch 1 at the branch office is a little more real world than our switch 1 at the corporate office, because this one actually has the VLAN interfaces. Shoop, shoop, all these guys right here. And then it has a single kind of point-to-point link, which is fast Ethernet 1/15. And that's why it also said all interfaces should be passive with the exception of fast Ethernet 1/15. So let's do it. So I'm going to go into, actually I need to open that connection up. Switch 1, branch 1, switch 1. And I've got a whole bunch of VLAN interfaces there. This guy's down. I'm not too sure why. But not our concern right now. Just the users, right? So we've got, oh wait, no, that's our lab, because we don't have anything in the lab yet. So let's go to router OSPF 1, router ID 1.1.2.2. That was from the lab. I've got that configured. And let's do, oh, we can't use network statements. It says we may not use network statements, so we need to go under interface FA 1/15 and do IP OSPF process ID 1, area 1. That's going to be on that point. Oh, good, good, good. I saw that neighbor form. On the point-to-point link between switch 1 and router 1, and I see that neighbor relationship has come up. But now we need to go underneath interface VLAN 64 and do the same thing. Add it to OSPF process 1. Now, some of you might be thinking, well, whoa, wait a sec. Why are you doing that? I thought we were going passive. We're not gonna use those interfaces. Well, careful. Remember, there's a big difference between a passive interface and an interface not added to OSPF. A passive interface just says don't send hello messages on those VLANs. An interface not added to OSPF says don't send hello messages and don't advertise these networks to anyone. Well, I don't want the second part. I want the corporate route office to know about all of the networks that exist over here. I need that information to relay. Otherwise, the corporate office won't know how to reach all the devices down here. So I want to advertise it. I just don't want to send hello messages. So this evil person right here on this PC forms a neighbor relationship with my router and destroys my network by sending bad network updates or something like that. So we still need to go through here, and let me get back to the config, and add all these things to the OSPF process. Let's see, 68, 9, 70, 71. Got to add them in there. We just then go back out under router OSPF 1 and do passive interface, and this is where this one saves a ton of work, right? Passive interface default. Turn it off on everything except for fast Ethernet 1/15. We can run it there, and that neighbor can now reform. You can see it just pop back up there. Reform between the two devices. Good. So we should now. I'm going to shoot back all the way over. And okay, last thing, and then we'll wrap up this part one, which is, I would say, the most test relevant stuff. Verify neighbors have formed, and verify all OSPF routes are there. So let's go show IP OSPF neighbor from switch 1. He's seeing this guy. Oh, we totally forgot the authentication, didn't we? Hang on. Let's fix that up real quick. We'll do, actually, we didn't do authentication at all over here. Let's do it. Interface. Now you see why I like this command, right? Oh, wait, wrong router. I'm on. See, I'm getting in a rush. I'm going to mess something up. Let's do, okay, fast use. Actually, both interfaces need authentication. So let's do interface FA0/0 IP OSPF authentication message digest. IP OSPF message digest key 1 MD5 Cisco. You know, a very smart person would probably just put all this in Notepad right now. Let me do that. All right, I pasted it over. I still got to put all this stuff in the answer key, but I'm going to cut that out. Go under interface FA0/1 and just paste. Save me some typing. Okay, so we've got the key configured there. Corporate switch 1. We need to go in interface FA 1/15. That's our connection to router 1, and paste that in there. No. Is that not going to work? Hang on. Whoa, what did I do wrong here? Oh, idiot, Jeremy. I'm on I see I'm moving too fast. I'm on corporate switch 1. I need to be on branch 1. Oh, good. Okay, good. The corporate switch 1, fast Ethernet 1/15 exists, but it's not configured as a routed interface. Okay, that's better. I thought, no way is that not supported. Okay, so that's good. So we've got the branch switch 1 configured. See, I'm going too fast. Something's going to break. I can feel it. We've got branch 1, router 1. That's configured. We need to go to corporate router 1, who lost his neighbor relationship. Go here and paste that in Shazam. That should give us authentication. Just to make sure I did it all. I just did it right here. I have it right here. Configured it there and configured it there. So we are now using authentication everywhere in the network. There we go. We've got loading to full. That's good. So now let's just verify. Let's go over to corporate switch 1, who is this guy over here, way at the back, and let's do a show IP OSPF. Wait a sec. Show IP route. I'm trying to rush and squeeze it all in, and I'm forgetting stuff. So look at this. This is good. Look at this. We actually are seeing all of the routes from area 1. You notice we're on corporate switch 1. So we're seeing all of the routes right here from area 1 as inter-area routes. That's the IA, inter-area, right there. Inter-area routes for OSPF. Right here we've got the WAN link, also considered inter-area, because from switch 1's perspective, corporate switch 1, that is out of its office. I come over here to the branch switch 1. And this guy should also see. I just go to the endpoints, because if these guys are getting all the routes, that means all the routers in between have to get all the routes. So we've got all these guys, inter-area routes, they're showing up. I'm seeing the WAN link right here as an intra-area route. It's just a normal OSPF route right there, because that WAN link is in area 1 as well. Good. So with that being said, let me wrap up. We've made it through objectives 1 through 3 at this point. After this, in the next nugget, we're going to get into the fancy stuff. Default routes, configuring summarization, all of that kind of stuff. So I hope this has been informative for you, and I'd like to thank you for viewing.